Hello guys. What I've done is I programmed my CPU, my emulator for my CPU. What I did first is I described how I would like my CPU to work. First, the terminal. I described first how my register should work, or how I want my CPU to work, my registers to work. I have 8 general purpose registers where I can store values or something. Then I have the ALU A and B. That's parameters like if you want to add two numbers together, you do A plus B equals C. It's mimicked here like ALU A, ALU B. Next, there are all the results. The ALU calculates everything and puts this back to the registers. They're shown here. They're only they're read-only because I don't want them to that anyone could write to them. The same thing is with the program counter and core ID. I don't want people to write into them because that would confuse the CPU and there are only values you could copy from or use. And then the memory address, you can specify memory addresses in this register, like I can say, hey, I want to have my memory address. I want to write to the memory address some values. As supported instructions, there are then the instructions I want to have. There is first no operation, like for pause or something, when I want to pause the program or something. The register, I take a register, in which register my program should save the register to, and then the source register where the value is from. Set register byte is just that I can select a register, select a byte, and write a value to that register, that byte on the register. Register write to memory. That means I want to write the value on the register to memory. The same here, but opposite. Like I want to take the value from the memory location and store it in my register. Jump. It's jump. Like I want to jump somewhere in the program. Jump if 0, then something for some condition, like if the value on the register defined as the second parameter is the check. That means you select the register which you want to check for if it's 0 or not. Jump if not 0 is the same but opposite, like I want to check if the value is not 0 and then jump somewhere. Alt should just stop the emulation of the CPU. Update updates the results on the registers. I've done it. At first, I programmed the ALU. Like I've written down which instructions I want to have, which functions I want to have for the ALU, like add, subtract, and or, for like simple arithmetic calculations. Update, then power, like 2 to the power of 8 is 256. I needed this for ALU to long. Like I want to take 8 bytes and convert it to a number. That's just I need this to work with the memory to get the 4 bytes for the instruction. And then ALU PC program counter increase. This means increase the program counter after each instruction. After that, I've done the main. I constructed some structs like for my core itself. Like I want to have 17 registers defined here with the length of the architecture. Defined in config.h. Like I want to have an architecture of 8, so that's 8 bytes. 64-bit. You can change this if you compile this. And then the core count, how many cores I want to have in my CPU. Yeah, and here is the CPU I constructed. It's like it has a RAM, the cores, and the status if the cores run, if the CPU is running or not. And then here are some definitions for my registers, some definitions for my instruction set. Here's some functions for call step when I want to do something in one core and one core only. CPU creates the CPU structure, like how the CPU should work, and then step is like go one step forward on the instruction set. And then here the CPU create, like as I said, I want here like define the register for the core, so that everyone who writes a program can easily read the core that I have. If I'm on core 0, that I know I'm on core 0, or 1, or 2, or 3, and so on. Step, it just does first steps. Code instruction, this means it takes takes at first the program counter, then it writes the instruction to callback. Check 0. This checks if 8 bytes or if a register are zeros, just for the instructions on call step, like I load here the instructions. Then case no op, this means no operation. What should it do for every instruction? Like here, I needed check 0 to check if the register is 0. And then halt sets the status to 0, so that any other program running sees, oh, status 0, oh, the CPU is finished, I can close the program now. Or update, this just updates the ALU. And ALU PC increase, you see it on the end of every instruction. This means just to increase the ALU instruction, ALU, the program counter. That should be everything. I have a test file here that's just for some test purposes. It compiles into a library format like cpmu.so or DLL on Windows, so that I can use it everywhere. I can use it like on other programs, like I have a building block here for every program I write where an emulator is needed, or if someone wants to mod the program and wants to have like a RISC-V CPU, just change it out with the same instructions as CPU-mu. You should only need these 3 functions at most program. That's everything. Thank you for listening, and now follows the coding process in short, like how I wrote this.